Hello and welcome everybody to my new video. This video is the third one in my series on soil physics. The first video in this series was about soil functions, so why is soil important for us, for humans and for plants. And water was one important topic, so soil is very important for storing water and for providing water to humans and to plants as well. The second video was about soil pores, which are important for water as well. And now the third video is about water potential. In the above you can see a symbol for the soil potential, and we will talk about in this video why the water potential is important and what it is meaning. What is the use of the water potential? Why do we need it? Let's have a look at this illustration showing the movement of soil water. First it's raining and the water on the soil is draining down, forming groundwater. Part of it is detoured to other places in the soil. And part of this water then is taken up by roots and is transported within the plants up to the leaves, and where it will evaporate and then migrate back to the atmosphere. And the role of the water potential is trying to summarize all the factors driving these movements. So why is a part of the water going directly down to the groundwater? Why is other part of the water moving into the plants? And which factors are determining this? This is the role of the water potential. And how is it done? Or let's better ask, what precisely is driving the flow of the water in the soil? Let's have a look at one factor that you all will easily understand. It's the position energy of water. So here you see a bucket hanging in a certain height, and if we turn this bucket, then the water will of course flow down to the earth. And this movement then is driven by the position energy of this water in this bucket. On the way down to the earth, this position energy first is transformed into kinetic energy, and when it hits the floor, it will be transformed into heat energy. And this transformation of energy and this position energy, that is the factor which is driving the flow of the water. Now we can transform this energy and refer it to a certain amount of water. In this case we take the amount of 1 mole or of 18 milliliters. And when we refer this energy to this amount, then we are speaking about the potential, in this case the gravimetric potential. And now if we look at the unit of this potential, then we become aware that this is the same as the unit of pressure. So if we have a look, if we divide energy by volume, energy is force multiplied by path, and it means we have to divide path by volume, and this means we divide force by area, and force by area, that's the same units as pressure. And it makes sense to have pressure here as the unit of this potential, since the movement of water in the soil is driven by pressure. It's not pressure that somebody is pressing, but it's rather suction, so it's negative pressure. So things are drawing the water at certain places, and we try to summarize these effects, various sources of negative pressure, by the water potential. Now I have shown you one driving factor for the movement of water in the soil, which is the gravimetric potential, and this potential of course is driving water to flow directly downwards. But there are other factors of course. On the one hand there is evaporation, which will also affect water on the surface of the soil, but there are other factors as well. One factor, for example, would be an osmotic potential. This is, in many cases, this is not very relevant in the soil. It's rather relevant within the plant, for example. But in some cases, for example, when there is a high concentration of sodium chloride in the soil, so of salt, then this salt has a certain osmotic potential. It will attract water and deviate it from the main flow downwards to the location where the sodium chloride is located. This would be the osmotic potential. Another potential, which is more important in the soil, is the matrix potential. This is a potential which is coming from soil pores. water has a certain tendency to cover surfaces, in particular surfaces, and the surfaces of soil pores have this tendency to attract water, and the larger the surfaces of the pores is, the stronger is the matrix potential, and this is a very important potential within the soil. There are several approaches of measuring the water potential within the soil. One approach would be to take a gypsum block with electrodes inside and put it into the soil, and then the more water is available in the soil, the more water will move into this gypsum block, and the stronger the current will become between the electrodes. When we do such measurements, which numbers will we obtain? Let's start with the water potential of pure water on the surface of the soil. This would be 0 megapascals. So the units here refer to the units of pressure. And when we go into the soil, there is a negative pressure, so that means water will actually be moving from the surface of the soil into the soil. Often, in many cases, this is not a very high amount of negative pressure, like 0.1 minus 0.1 megapascals. So plant roots have a stronger negative water potential, ranging from minus 0.2 to minus 0.4 megapascals in the typical case, the root system of the plant. The leaves of plant have even more negative water potential, ranging from minus 0.2 to, let's say, minus 1 megapascals. In some cases, leaves of trees, for example, they can have even more negative water potential of minus 2.5 megapascals. The atmosphere then has a very negative, strong negative water potential of minus 94 megapascals, for example, for 20 degrees Celsius and 50% humidity. In the soil, water is always flowing from positive values to negative values, so it will flow from the pure water on the soil surface into the soil, then into the root system, and then inside the root, inside the plant, upwards and into the atmosphere. The capacity of plants to extract water from the soil is ending when the soil reaches a water potential of minus 1.5 or minus 2 megapascals. Then plant roots can no longer extract any water from the soil. They simply, the plant simply has not the possibility to achieve a more negative water potential, and this means the plants will be in lack of water. They will start wilting. Other important values, if you look at pores. So in the last video I have spoken about pores and about different sizes of pores. Megapores, which are pretty large, have a very weak water potential of only minus 0.03 megapascals. Mesopores and micropores range up to minus 1.5 megapascals. This means they reach the permanent wilting point. So the water within these pores is available for plant, but water within the ultra micropores below minus 1.5 megapascals is no longer available for plants, though they will not be able to extract this water within the ultra micropores. While this is all well and correct, you have to be aware that this is only part of truth. The other side of the truth is that this only is a water potential, so it only shows possible flow of water in case water is actually able to flow. In case water flow is blocked, then the water potential doesn't matter anymore. For example, if there is a clay layer below this water on the surface of soil, so if the water flow is stopped there, then the water will not go down and will not follow the gravimetric potential to go down to the groundwater, but it will stay on the surface of the soil. In a similar way, if, for example, the plant decides not to let transpiration go ahead, if the plant decides it has to reserve its water, then the water will not go out into the atmosphere and will evaporate from the plant. The plant is able to block the flow of water at the surface of its leaves. So the leaves are covered by a wax layer and they have little openings, and the plant can decide to open or to close these openings, and this will decide whether there's really a water flow from the plant into the atmosphere. In this video I have shown you that the water potential is very important for measuring and for predicting the flow of water in the soil. Another very important factor were soil pores, and I will speak about the connection between soil's texture and soil structure and soil pores, and so water potential as well, in the next video.